And chapter 2 is on data, reality, and problem solving. All right, and 2.1 is on measurement. So some questions that come up when we talk about measurement. Do we have good measurements? Is the concept under the study adequately reflected by the proposed measurements? You don't have to write all this down because this isn't really term and answer, terms with definitions or anything. This is going to kind of talk through this. I'll write down any important terms or anything that you would need to know for homework or test or anything. But when we talk about measurements, think about whenever you're measuring things. If you're measuring people's heart rates and maybe you're not using the correct technique, or if you're checking somebody's cholesterol, is the concept under study adequately reflected by the proposed measurements? If you're taking people's heart rates and maybe they come into your office, you take their heart rate, and then they go to the waiting area, but your office is on the 3rd floor and the elevator's broken that day. I don't know. So, there are lots of things that could come up that could skew your data. So you need to make sure that when you do measure data, is it adequately reflected by the proposed measurements? Is the data measured accurately? Of course. If you're using some device to measure and that device is messed up, we have a thermometer at our house, and whenever I take my temperature, it always comes up like 96.4, and that just seems kind of low to me. But my wife still uses it, so I don't know. Is that good data? If I took my temperature every day and it was 96.4 every day, should that lead to believe me that or make me believe that my temperature is that low all the time? Well, if I had to guess, it's probably a little bit off, maybe a degree or so. I don't think I'm that cold-blooded. Is there sufficient quantity of data to draw a reasonable conclusion? So, if I use that thermometer for 3 days and it says 96.4, is that enough data, or should I maybe measure it for the next month and just see? Or should I just go buy a new thermometer? I don't know. But sometimes people, like if you're having your blood pressure measured, every time I go to the doctor, I have my blood pressure measured. Most of the times it's pretty good. The doctor doesn't say anything. But like the other day when I had to go to the doctor, it was like 140 something over 100 and something, which is really high. I had a really stressful day at work. I drank way too much caffeine. I drank a Red Bull mixed in with Diet Mountain Dew. So I'd done some things that day. I went when I was going to Jackson. It was like rush hour traffic, so I was like so mad at everybody. And a lot of things, all those things can factor in the blood pressure. And so I said, well, I've had a pretty rough day at work. And she said, well, maybe that's it. And so, but that's the first time it's been that high. Usually it's like 120 over 80 or something like that, which is pretty good, I think, anyway. They tell me it's okay. But just keep an eye on your blood pressure, and if it is high, maybe you're stressed out, maybe, maybe different things are going on that can affect that. All right, 2.2 is on science and data, and this is let's see, just one second. So what are the methods for exploring the research problems that you may have? Well, there are certain methods that have been used, have been developed to gather statistics. One of these methods is known as the scientific method. That kind of sounds familiar. What is the scientific method? With the scientific method, we gather information about the phenomenon being studied. On the basis of the data, we formulate a preliminary generalization or hypothesis. Collect further data to test the hypothesis. And if the data and other subsequent experiments support the hypothesis, it becomes a law. Statistics and data are fundamental to the scientific method. Data from carefully designed experiments are the ultimate evidence that support or discredit new theories. We will revisit hypothesis testing somewhere near the latter part of the semester. Hypothesis testing is important when conducting an experiment so that you'll know whether to accept to reject or fail to reject your hypothesis. Okay. And that is the end of 2.2.